Okay, so this video is for Math 70, and this is a follow-up video on solving linear equations. So let's just get right to the problems here. Take a look at a few of these. This one's this assignment's a little bit shorter than the previous one. So in problem 2, we start out with 2/3 y plus 8 equals 1/4 y. Okay. So this is pretty straightforward, and again, you have a calculator. I encourage you to use it. Most calculators can handle fractions pretty well. These graphing calculators are not the greatest. They revert to decimals pretty quickly. You can still do this with decimals, but if you get a repeating decimal, you do have to be careful. So let's just go ahead and look at the problem. Basically, what we want to do is subtract 2/3 y on both sides. The tricky part is the computation, or the calculation, okay? So, if we want to do 1/4 minus 2/3, I'll go ahead and do it on the board. Let's see, this one's going to be 3/12, right? 1/4 is 3/12, and then 2/3 is going to be 8/12, right? Here I multiplied by 3/3, and there I multiplied by 4/4, and so if we subtract, we're going to get -5/12 y. -5/12 y, and then I would multiply on both sides by -12/5. Those cancel out, and here y comes out to be -96/5, or -19.2. Either one of those answers is fine. Okay. All right. Let's look at this on the calculator. So if I go in here and I go 1 divided by 4. So on the graphing calculator, the fraction bar is the divided by symbol, which I think is a good thing because the fraction bar means divided by. So it's good to get used to that. All right. 1/4 minus 2/3. And then what the calculator comes out with here is -0.416666666667, which is of course not correct. Calculators don't handle repeating decimals very well. They round off instead of actually representing a repeating decimal. Okay, so here's our answer right here. So you could have said, all right, so 8 is equal to -0.416 repeating y. And then if I wanted to do 8 divided by -0.416, and then I'll just hit the 6 a bunch of times, you know. Usually 7 or 8 times is enough for the calculator to get the idea of what's happening. And so if I do that, those cancel, and here's my answer right here, -19.2. Now, let's say I didn't, let me show you what that looks like on the calculator here. You can see I went a little overboard typing in those 6s. Now what if I didn't go overboard in typing up those 6s? Okay? What if let's see, sorry, I should have kept this. There we go, focused on there. Now what if I had just done 8 divided by 0.4166? Oh, we need a negative in there. There we go. -0.4166. You can see it comes out a little bit off. Okay? So here's the thing. If your rounding is bad on the number that you enter, then you should know that you're going to have to round this answer off. Okay? The more 6s you put in there, the closer to 19.2 your answer is going to get. So, it's just some tips on handling calculation with a calculator and repeating fractions, repeating decimals. Because for whatever reason, I suspect what's going on is that it would just be too expensive for the calculator companies to make one that can really handle repeating decimals. I don't see anything preventing it other than price. I think that if they go to all that trouble, it may do something to the price of the calculator that they would be unhappy with, and the customers would also be unhappy with. But that's just a guess on my part. All right, Let's look at problem 4. 0.06 times 100 minus k plus 0.04k equals 0.05 times 96. All right, so we've got some distributing and some multiplying to take care of. 0.06 times 100, and I encourage you to use the calculator to make sure that you're not making any errors. And I'll do that for this one. This one's a little bit trickier than 100 times 0.06. This one is 0.05 times 96, and that's going to give us 4.8. Okay, so over here I've got negative 0.06k and a positive 0.04k, so that's negative 0.02k. And again, if you're not sure, go ahead and use the calculator. There's nothing preventing you from doing that. All right, this negative sign, right, is attached to the negative 0.02k. This 6, this is what I was talking about last week when we first started talking about combining like terms and everything. The sign for a term is always in front of it. That's a positive 6. If you want to move it to the other side, you're going to have to subtract 6. This will stay here, negative 0.02k is going to be equal to 4.8 minus 6. That should be negative 1.2. And then we'll go ahead and divide on both sides by negative 0.02. And let's see. Looks like it's going to come out to be 60 there. Is that right? I believe so. Negative 1.2 divided by negative 0.02. Yeah, 60. Okay. All right. Let's see here. Well, let me just plug that in and double check it. So 0.06, 100 minus 60, and then 0.04 times 60. So this is 0.06 times 40 and 0.04 times 60. Let's see. So this is going to be 2.4. This is also going to be 2.4, and they're going to add up to give us 4.8. So yeah, that answer is correct. All right. Let's look at problem 6 here. 7a minus parentheses 2a minus 9 equals 39. Right? So the subtraction sign, or that negative sign in between the 7a and the parentheses, means that this 7a is just going to stay here for a minute by itself, and that there's a hidden 1 right here. This is like distributing a negative 1, and we want to distribute that into the parentheses, so that'll be negative 2a plus 9, or 5a plus 9 equals 39, and from there it's pretty straightforward. This will be 30, divide on both sides by 5, and a equals 6. Okay, let's see here. Problem 8. Problem 8, there's really not a whole lot to do here. The only thing that's tricky is that you have decimals. But, you know, you've got a calculator, and you don't even really particularly need a calculator to do this problem. Maybe the dividing at the end would be a little bit tricky. But really, actually, we don't even really have to divide. Look at what's happening here. 2.3 minus 1.3 is just going to be 1x. So we're not even going to have to divide to figure out this answer. All we have to calculate is 2.9 minus 13.7. And let's see, what is that going to give us? That should be negative. That'll be 10.8. Negative 10.8. Okay, so there's that one. Like I said, there's not a whole lot to do in that one. I think it's a little bit tricky because of those decimals, but nothing really so awful. Same thing with problem 10. There's no decimals here, but it's a very straightforward equation, right? You've just got variables and constants on either side of the equation, and we want to collect our like terms, right? So we're going to move the 3y over here to be with the 6y. And then we'll add the 9 over here to be with the 12. That gives us 3y equals 21. And then divide by 3 on both sides. And there we go, y equals 7. Pretty straightforward. Okay. Problem 12. Problem 12 is a little bit tricky because of the fraction. So let's see what we've got here. 5/16 x plus 3/8 x equals 2 plus a fourth x. So this is all about adding these fractions together, right? We've got to add 5/16 and 3/8. And again, feel free to do this on the calculator if you'd like, but do be careful with your estimations and the issue of repeating decimals. These decimals won't repeat for something, a reason I find kind of interesting, but I won't get into right now. It has to do with these denominators. But these are all terminating decimals, and so there's no reason to round them off. Let's see. If we wanted to turn this into sixteenths, it would be 6/16. And so when we add these together, we'll have 11/16 x on one side, 2 plus a fourth x on the other side. So now we want to subtract this 1/4 x on both sides, and this is going to be 4/16, right? If I multiply by 4 over 4, so 11 minus 4 will give us 7/16 x equals 2. And then, you can divide on both sides by 7/16 if that's what you're in the habit of doing, right? If you're going to do this on a calculator, do be careful and be sure to put the parentheses in there. And this will come out as, what is this going to be here? X equals 30, looks like 32 over 7. Well, let's double check that. Make sure that it's true. All right, so 5/16 times 32 over 7. 3/8 times 32 over 7. Is that going to be 2 plus a fourth times 32 over 7? So we'll see some canceling here. There's 10 over 7. There's what this is going to be, 12 over 7. 2 plus 8 over 7. All right, so what do we got here? This is 22 over 7. This one is 14 over 7. 14 and 8, 22 over 7. All right, so that one's a little bit tricky. If you come out with a decimal in this case, it's not immediately obvious that it's a repeating decimal. These sevenths have a kind of weird way that they repeat. 1/7 is 0.142857, repeating. Okay, and all of the sevens do something like that. Okay, so that's kind of a tricky one. I tend to kind of take it easy on people if they round this off, even though it is a repeating decimal. But when it comes to the thirds and the twelfths and so forth, it's pretty easy to see that those are repeating decimals. Okay, so let's see. So what would this come out to be as a decimal? This would be 4.57142.8. Okay, it's the same digits in the same order. It's just this one starts with the 5, 5.7.1.4.2.8, 5.7.1.4.2.8, and so on. So if you rounded this off, if you called it 4.57, that's fine. I'm pretty understanding about that. Okay, last problem, number 14. Let's see what we've got here. 2 minus b plus 4 equals 3b plus 8. All right, so again, we've got this -1, needs to be distributed. The 2 stays the way that it is. And then we get 2 minus b minus 4, 3b plus 8 over here. Okay? Let's go ahead and add the b. That's 1b. So these will cancel out. That'll be 4b plus 8. This is negative 2. And then we'll subtract the 8 on both sides. 4b is negative 10. Divide on both sides by 4. B, negative 2.5. If you want to call it negative 5 over 2, that's fine as well. They're both correct. Okay. All right. So that's it for this assignment. We'll move on. We'll look at another method of solving equations in the next assignment. And as always, if you have any questions, please let me know. Thank you.